start with the equation that's in your manual. It's also in your lab notebook under the manual section of your notebook. But you're going to make an assumption based on the equations that if you have two different molecules that we're looking at, like we are in this lab, where we're looking at water and ethanol, in the equation, you picked one of the letters A or B to be one molecule and one to be the other. Here I'm going to say Anna's A, Joshua's B. We'll pretend those are molecules. And let's say you started with a 50-50 mix of each one of those. The mixture that you got for distillation lab is actually a volume ratio, not a mole to mole ratio. So your answer there cannot be 1-to-1. It may be close, but it's not going to be 1-to-1 because it's a volume, not mole ratio. And then from there, we're going to determine the mole fraction by using the equation. So we need to have your refractive index value, and that refractive index value is going to be the one that you measured at 20 degrees Celsius. If you did not measure it at 20 degrees Celsius, you're going to need to do the calculations to convert it to 20 degrees Celsius. So on the digital refractometer, you can make it do the math for you. Otherwise, if you did not, you're going to have an error in the information without doing the calculations, and the calculations are in your manual. So from there, we're going to need to decide on how to do this calculation, but first you're going to need to determine what is the refractive index of the pure solutions, and I'm going to make up some. So for the molecule Anna, I'm going to say it's 1.35. For the molecule Joshua, I'm going to say it's 1.38. I'm just making up these numbers. Clearly these are not molecules, and I don't know what the answer is going to be when I do the math because I'm just making these up. So from there, we can say if the mixture is 1-to-1, we can use this information to determine what is the mole ratio, like how many moles of one to how many moles of the other is in the solution. So I measure my sample. It turns out the mixture, the refractive index is 1.36. I'm just making up these numbers. I don't know what you got. So we're going to plug that into the equation. So again, I'm going to write down what it is I know. Here's the equation. Again, you have to use the corrected value. You can't use the one at whatever temperature you feel like to. So I'm going to say that since I said Joshua's B, I'm going to say XB is the mole fraction of Joshua, and XA is the mole fraction of Anna. And then I'm going to go back, and I said that my refractive index at 20 degrees, the standard value is 1.35. The standard value for B is 1.38, and what I've measured for the mixture is 1.365. So I'm just going to be plugging that into the equation. I plug that into the equation, and that's what we're going to do here is we're going to do the math. I'm not going to remember all the numbers, so I have to keep looking back. Again, if you did not measure at 20 degrees Celsius, so you didn't do ND20, you have to recalculate it at the 20 degrees. So when I do the calculation, I just fill in everything. I get when I subtract, I get 0.015 minus 0.03, and that turns out to be 0.5, I think. So if XB is 0.5, that means XA must be also 0.5. So I just happened to randomly pick a number, and it turned out that they're actually 1-to-1, but that's not necessarily true. That's just because I picked random numbers, and I just got lucky. So if your values are outside of the range of the two standard values, like it's much higher than the highest one, or much lower than the lowest one, that means there's something wrong with your calculation, or something wrong with your sample, or something, or not calculation, but something wrong with your sample. Either you didn't clean the refractometer properly, like it wasn't dry enough before you used it, or you did something wrong in your sample, or you didn't measure it at ND20, you measured it at some other temperature and you didn't pay attention to that, or that your sample is possibly contaminated because you're only using water and ethanol in this lab and there was nothing else. The chance that you contaminated your sample, or your sample is contaminated with something, is almost unlikely. So I'm going to say it's pretty much that's not going to be the case in this lab. And I know that word, it should have said contamination, but I know it says contaminate something. I don't know. So try to do this with all your samples. If your values are out of the range, if it's closer to one or the other, then you can say it's likely. Like if it's closer to A, then you say, okay, it's likely A or it's likely B, but you can't give a number. Like you can't say what the actual value is.